we are going to write fractions as decimals and divide integers. So we're going to express quotients in different ways as well. Not letting me know when people are coming in. That's weird. All right. So Haley is buying herbs. She wants to buy 5/6 of an ounce of basil. The scale she is using to weigh the basil displays the weight as a decimal. How will she know when the display on the scale is correct to the tenths place? All right, so our scale is going to weigh in tenths. And then we get 1 pound, right? All right, so she only wants to buy 5/6 of an ounce. So how will we figure out, or how will the cashier figure out how much basil she has using this scale? What can I do? What can I do with that fraction?
Divide 100 or 1 by 6 and then multiply that by 5.
All right, explain that to me. Divide 1 by 6. I'm just confused with what you were trying to do. I think you were kind of thinking on this line, right? Try to get the 6 to 100, or 5/6 to 10. Yeah, we could do it that way. Unfortunately, though, 6 doesn't go into 10 evenly, but we could try it. So it goes in there one time, right? Oh, it wouldn't be -4, it'd be -6. And I would get 4 left over. And then 6 goes into 40 how many times? Okay, someone said 6. I did hear that. And then what do you notice happens? It's going to start what?
Miss Lavelle?
Yes.
My sound doesn't work, and neither can I type.
Okay, the only thing I can tell you is shut your computer down and restart it. That's the only thing I can tell you.
You'd have to type it in the... What'd you say? You'd have to type it in the chat, because I can't hear you.
Okay, so that sometimes changing fractions into decimals don't always give you the instant correct answer. So 5/6 is a repeating decimal, as we just figured that out, right? So if I only take 1.6 and multiply it by 5, I'm only getting 8. But if I take 1.66, which is the repeating, and multiply it by 5, now what do I get? I get 8 3/10, right? So sometimes you have to be careful with repeating decimals, and 5/6 is a repeating decimal. Okay? So really, 5/6 would fall between 8/10 and 9/10.
I have a question.
Yes.
If it's a repeating decimal, how do you know how long you're supposed to go for?
Well, a lot of times you can stop once you realize that it continues to repeat. So like when I had 40 here and I subtracted 36 and I got 4 again, I knew right then it was going to repeat, and I stopped and made it 1.6.
Oh.
So sometimes, though, it may ask you to carry it out into the hundredths place. It may ask you to carry it out into the thousandths place. So it's really kind of where are they asking for you to stop it. Okay? But I'm just letting you know that when you convert decimals, sometimes you have to be careful. Because I think I gave you that example, right? So if I add 1/3 plus 1/3 plus 1/3, I get 3/3, which is 1, right? But 1/3 is a repeating decimal. So if I add 0.33 plus 0.33 plus 0.33, I only get 99 cents. And if you were to put 99 cents in the test and the answer is actually 1, it would be marked wrong. So that's why I say be very careful about converting fractions to decimals and trying to add them together and find things out. So, I've been teaching for a while, and I've had teachers in elementary school to tell kids, oh, just convert it to a decimal and add them. Well, that teacher did not do you guys justice by telling you to do that, because it doesn't work that way for all fractions. As you can see with a repeating fraction, you get a different answer. It's close, but it technically is different, right? 99 cents is definitely different than $1. So you just have to be careful when we're dealing with repeating fractions. Okay? All right. So if we're looking at the on your own, it says, what do you think the digit in the hundredths place of the display would be? Well, we figured that out, right?
On your own.
Huh?
You just said on your own.
I'm sorry, the turn and talk. Give me a second.
5/6 ounce of basil, and that's not 1, but it's 8.3 or 8/1/3. So.
Well, actually, you're right. It wouldn't be 8.3. What would it be?
0.8.
Yeah, thank you. It would be 0.83.
That's what I was wondering.
Yes, I'm sorry, Xander. I did that wrong. Yes, Jaden.
And Miss Lavelle, my device is about to die, and my computer kind of stopped working. So
Okay.
is this going to be videotaped?
Yes. I will try my best to get it uploaded today, but once again, my daughter has soccer, so it
Because
just...
today really is
Yeah.
not my day.
Okay. All right. I'm sorry. All right. So what number would be in the hundredths place? So if,
3.
yeah, it would be another 3, right? So if this is tenths, hundred, oh, this is thousand. So it would be a 3. All right. Whew, took too long to get through that one. All right, so let's look at our lesson. All right, so Haley wants to buy amounts of herbs shown. How can you convert these fractions to decimals? You can use equivalent fractions to convert a fraction to a decimal. Does that method work well for these fractions? Why or why not? So we have 3/4 ounce of oregano, and we have 2/3 ounce of thyme, however you say it. Okay, so what? Okay, so what can I convert these to? And how can I convert them? Anybody know?
3/4 could be 0.75 and 2/3 could be 0.50.
Oh. 2/3? How did you get 0.50?
I think you should do 0.66.
Oh wait, I'm dumb.
You probably thought 2/4.
Alright, so let's think about 2/3. We know what 1/3 is, right? 0.33, right?
So 2/3 is 0.66.
How did you get that?
Well, you just add 0.33 twice.
Yeah, so if 1/3 is 0.33, repeat, right? 2/3 is double this, so it would give me 0.66, repeat. Absolutely. So the question says, does the method work well for these fractions? Well, it works well for this one, right? But it doesn't work well for 2/3. So, works well with this, not well with this. And the reason why is because it repeats.
Why do some people, they add, on Google when you do it, they add a 7 at the end.
So what happens is, and your calculator will do it as well, is once the calculator gets to the end, there's no more numbers that it can continue going. So it just automatically rounds it to the next number. If it's, 5 or higher. That's just the way it does it. I can't explain why. Why doesn't it just do, put a 6 there? Why can't a calculator, someone invented a calculator with a line over it? I have no idea, Xander. Yep.
Okay.
Yep. It's a good question. All right. So you can also use long division to convert a fraction to a decimal, because A divided by B is A divided by B for all fractions A, B. All right, hold on. I got to let somebody in. All right. So it says, think about dividing 3 ounces into 4 equal parts as shown. How many tenths and how many hundredths where there'll be in each part? So how many tenths?
7.
Yep. So 7 tenths.
And then 500.
Yep. And then 5 hundredths. So that's all it's asking you. So 7 tenths and 5 hundredths. All right. How can you use the decimal form of 3/4 ounces to find what Haley will pay for basil that costs $5.80? So what would I do? If I had 1 pound, I would do what? So if I had 1 pound, how much would that cost? Guys, it's not a trick question. And I shouldn't say 1 pound. My bad. I see the question. I see the problem. Okay, if I have 1 ounce, what would it cost?
$5.80.
Thank you. I asked the question wrong. That was my fault. If I have 1 ounce, it would cost me $5.80. But now I only have 3/4 ounce, and so technically I would have multiplied the 1 times $5.80, right? Well, you do the same thing for 3/4 of an ounce. $5.80 times 0.75.
I'm thinking guessing at dividing it by 4 and then multiplying that by 3.
You could. You could. Absolutely.
That's the longer way, though.
I could have done $5.80 times 3 divided by 4. Yep. But what did the question ask me to do, though?
Oh, decimal.
Yeah, use the decimal form. Would you have gotten the same answer at the end? Absolutely. And if it was a test that only wanted right and wrong answers, then absolutely, I would have you would have gotten it right. Okay? All right. So now it says use long division to find the decimal equivalent of 2/3 ounce to the thousandths place. Well, we kind of already know what this answer is, right?
Are you on the first one you need to be on to get the article done?
Hold on, Miss Capel, you're not muted. Now you are. Okay. So 3 divided into 2.0. So we know it's 6, right? Because we know it repeats. So this is 18. So 20 minus 18 is 2. So Reagan, see how they're telling us what to continue to divide out to? So I'm going to add a 0. I'm going to bring it down. So I know it's 18 again. So here's my 6 here.
And then the number 6.
Yep. Add another 0. Bring it down. 18. 6. And then I'll have 2 left over. So here they wanted us to carry it out 3 places. Okay? So it says to the thousandths place. Yes, ma'am.
What if they don't tell you exactly like which place you should keep going to?
Then just round it to 0.6, repeat. Yep.
Okay.
Yep. Once it starts repeating, you're done. Okay? So this would be 0.66 ounces, because that's what it's asking for.
So let's say that they didn't ask us for the thousandths thing. Would the answer be 0.6 or 0.66?
It would be this right here. If they didn't tell you to go to the thousandths, that would have been your answer.
Okay.
Okay? And guys, that line denotes that this number repeats. So this is different than this. Because this technically is 60 cents. And really, because this repeats, this is 66 cents. So there is a difference, because my fourth period class was like, oh, I keep forgetting the line. There's a difference. You cannot forget that line, because it represents a different amount. Okay? And there is a question that I know on your test that's probably going to ask you to put the repeating decimals in order from least to greatest versus terminating. So you're going to have to know if it carries out, what would it be? Okay? All right, so this says describe the pattern in the quotient, where the pattern continue if you write a 0 in the tens place of the dividend and continue dividing. Well, we already saw that. I wrote a 0 in the tens place and I got a 2 left over. Then I wrote a 0 in the hundredths place. I got a 2 left over. Then I added 0 in the thousandths place, and then I got a 2 left over. So yes. So the number 6 repeats. And the reason why is I continue to get 2 as a remainder. All right, and then we've kind of already answered the turn and talk. Can the number 20 be divided evenly by 3? No. We continue to get 2 as a remainder. So, no. And you can put, it will repeat forever. You will continue to get that 2, and it's going to repeat forever. There's a reason why it's called repeating and not terminating. Terminating means it stops. Repeating means it goes on forever. Okay, any questions on that? All right, moving on. Number 2. So every quotient of an integer is a rational number, provided that the divisor is not 0. Every rational number can be written as a fraction in which the numerator and the denominator are integers. The fraction can be written as a decimal that either terminates, which I said it ends, or it repeats. So for example, 3/4 is a terminating decimal, and 2/3 is a repeating decimal. The bar over the 6 means that it repeats forever. Okay? All right, so A says, suppose Haley wants to buy 2 5/6 ounces of basil. Complete the statement to show that 2 5/6 is a rational number. All right, so if you remember, a rational number is anything that can be written as A divided by B. Okay? So right now I have a mixed number. What can I do to that to get a fraction that is just A divided by B?
You can take out the whole numbers.
How do I get rid of that whole number?
You multiply 6 by 2 and then get 12 and add the 5.
Yep, so what do I get?
Fraction. 17.
Yep. So now this is considered to be rational. This right here is not rational. This is rational. So that means the 17 and the 6 are integers. So this is rational, and now that I have a rational number, the numerator of 17 and the denominator of 6 are considered integers. Okay? Complete the long division shown to write 2 5/6 as a decimal, and then complete the statement. So we're going to go up here. So we're going to do 6 divided into 17. So we know 6 goes into 17 2 times, and we know that because of that whole number right there. So 17 minus 12 is 5. Here's my 0. I bring it down. 6 into 50
is 48.
So 6 times 8, right?
Yeah.
All right. So 50 minus 48 is 2. Add my 0, bring it down.
Oh man, just repeating again.
Okay. So 6 into 20.
It's 30.
Oh, you're right. Not 2, it's 3. Which is
And
8.
then you'll start repeating.
Yeah, so hopefully you can see. So I get 18. Subtract the 2. So add a 0. Bring it down. Minus 18. So you can see they wanted you to go one more place. And then from there, I can write my bar. Okay? So 2 5/6 is 2.833 repeat. Does it terminate? Well, I've already said repeat, so it has to be repeating. Okay? Questions on that one? All right. So, the 3 ways that you can write an equivalent fraction with integers. So, I could do a positive in the numerator and a negative in the denominator, and I get -5. I can do a negative in the numerator, a positive in the denominator, and still get -5. Or I can have the negative on the outside and just divide 15 by 3 and still get negative 5. So all three of these, no matter where they put the negative, are considered equivalent. Okay? So this is the verbiage of the standard. And this standard is 7NS 1.2b. And it basically states that you as a student will realize that this, and this are equivalent. And that's pretty much the gist of the standard. So negative in the numerator, negative in the denominator, and negative on the outside are all equivalent. All right? So then C says, and there's, I think, one like this on the test too, where they give you a scenario and they want you to know, which one of these would represent it. So it says, suppose that the value of a share of stock decreased by $15 in 3 days. Which expression here would represent the average daily change?
First, you would can I?
Yeah, go ahead. Go ahead, Fox.
Basically, you would put negative 15 over 3, and then you divide the change, which would be minus 15, and then by number of days.
Right. So this was the second scenario, because they ask you from up here which one would work. And so it was the second scenario. Okay? Good. So the turn and talk says, can negative 2 and 5/6 be written as a rational number?
If you convert it,
Yep.
I guess.
So what would I convert it to? Over 6,
17
right?
over 6.
Yep.
Negative 17 over 6.
And then 17 is an integer. And I can make 17 negative if I want to. And then 6 is an integer. Yep. You got it. All right. Last one.
Wait, I have a question.
Okay?
So, will we have time to do the on your own tomorrow? Or
Yes.
Is there
Yes.
or are we doing lesson 4 tomorrow?
I think you're doing the on your own tomorrow. Let me double check though. Tomorrow's 5-3. You're going to do the on your own tomorrow.
Okay.
Okay? All right, so last one. What are some different ways that you can express the quotient? Negative 100 divided by 11. So what are the 3 ways I can write that?
Negative 100 over 11.
Yep. What's the next one?
100 over negative 11.
Yep. And then the last one is?
100 over 11.
Yep. That's it. Those are your 3 ways. What'd you say, Xander?
It's actually negative 111.
Yes, that's how you would say it. Yep. All right, so now we're going to express the quotient as a mixed number. So this would be negative 111. So we know that 11 goes into 199 times, and the reason why is because they already told us it was negative 9, right? So 100 minus 99 gives me 1. Add the 0, bring it down. So 11 into 0 is 0. And so I'm going to stop right there because they want it as a mixed number. So as a mixed number, my remainder is 1. So my mixed number is 9 1/11. But as a decimal, I got to continue to divide out. So as a decimal, here's my remainder. So I'm going to add a 0. Actually, this would have been 10, right? 0, yeah, 0 minus that would be 10. So then I add a 0 and bring it down. So 11 into that is 9, which is 99, which leaves me with 1. Add a 0. So hopefully you can see what's happening. It's repeating, right? So that's a 0 there. So then this becomes 100. So minus 99, which is a 9. And then 1 is my remainder. So my decimal equivalent is negative 9.09. Why is this not focusing?
The repeating is 0, 9.
Right. So I could stop it there. Or I could write it this way. You may know what those dot, dot, dots mean.
That it keeps going?
Yeah, that the pattern keeps going. So it means that it's still going to be 0, 9, 0, 9, 0, 9, 0, 9, 0, 9, 0, 9 until infinity. That's exactly what it means. Okay? All right. We are to the check understanding. So spend the last 5 minutes working on that, please. And then we'll check it tomorrow to make sure you guys have the right answers, okay? All right, but work on that for the next 5 minutes.
Miss Lavelle,
Uh-huh.
my laptop's about to die.
Okay. It's about time to go anyway. You got maybe 2 seconds. All right. I'll see you tomorrow.
Bye, Miss Lavelle.
Okay. Bye-bye.
Bye, Miss Lavelle.
Bye, guys.